Hello everyone, welcome to this channel Chemistry Lover. So in this video I have told you the ProR and ProS designation. So what is ProR and ProS designation? So let us understand this theory following some example. So I have written here a molecule. You can see it is not a chiral center, so that's why I have written here the pro-chiral center. You guys, I hope see this word prochiral. So what is prochiral? I hope you know the chiral one. Chiral center, the one which having four different groups connected with it. But this is not chiral because these two hydrogen atoms are similar in nature. Though the OH and methyl are two different groups, but these two hydrogen are same. So if we replace any one hydrogen by any kind of group like deuterium, you can consider here. I have considered deuterium because deuterium is another isotope of hydrogen. So I have considered deuterium in place of H1. So if we determine these two hydrogen atoms, that whether it is ProR or ProS. So first of all we need to check the priority of the pre-existing group at first, because here OH has the higher priority, methyl has a second. According to the atomic number, OH is first, methyl is second. So these two hydrogen atoms, between them any one I have chosen, like H1 is replaced by deuterium because I want to determine whether it is ProR or ProS for H1 only. So you can forget about the H2, right? In this case I have only considered H1. This H1 is replaced by deuterium, and here I have replaced H1 by deuterium, and you can see 1 to 2 to 3 rotation is anti-clockwise and lowest priority below the plane, so it is S configuration. Thus H1 is ProS, because while I have replaced H1 by deuterium, it is S configuration. So H1 is ProS. Similarly, when I have replaced H2 by deuterium, it is R configuration, because 1 থেকে 2 থেকে 3, so 1 to 2 to 3 rotation, still anti-clockwise but lowest priority above the plane, so it is R. It is ProR. So ProS and ProR refer only the condition of the molecule where central carbon is not chiral, because it is not chiral at all. As I've told you, these two hydrogen are same in nature, but it is chiral, right? So when I have replaced these two hydrogen atoms by any kind of group like deuterium in this case, then I have considered the central carbon is chiral only. So this is the ProR and ProS descriptor. So Pro here indicates the condition before the chiral in nature. That is chiral nature. The central carbon is not chiral, but here the central carbon is chiral one. So the condition just before getting chiral. All right. So another example shown here. Another second example, you to see the, I hope you guys see another example I have represented. Also it is not a chiral, you can see, because these two methyl are same in nature. Carboxylic and chlorine, these two are different, I agreed, but these two methyl are similar group. So a chiral center should contain 4 different groups, but these two groups are same, right? So it is not a chiral, but it is prochiral. So the stage just before the chiral, we can consider the prochiral. So methyl 1 is replaced by 3. Here I have not mentioned any specifically group, like the just before I have considered deuterium in place of hydrogen, but here you can replace any kind of group in place of methyl 1. I have considered 3. 3 is a random group. CD3 is also taken. That's in case of hydrogen you have used deuterium. It is also applicable, but I have used only 3. So 1 to 2 to 3 its rotation clockwise and lowest priority below the plane, so it is R, and that's why I have mentioned it is pro R. Similarly pro S. So a trick you also used here, then while you are going to determine pro R and pro S of any group within a molecule, then if it is pro R, then automatically it will be pro S, because if the methyl one is pro R, right, because 1 to 2 to 3 rotation is in clockwise direction, lowest priority below the plane, so obviously it is R configuration, hence methyl 1 is pro R, then automatically methyl 2 will be pro S. So that's it up to this. If you have any query regarding this topic, please ask me through the comment section, and if you like this video, then share it with your friends, those are interested in organic chemistry especially. Thank you.